Okay, the second derivative, those of you guys don't know what is the concavity is. How many of you guys don't know what do you mean, what I mean concavity? Like, do you guys understand what I mean by concavity? How do I tell if it's a concave up or concave down?
If the second derivative is positive or negative?
No, but how do you tell the function is concave up or concave down? Like, which part of the function is concave up, concave down? No. If I look at original function, what's the best way to identify a concave up or concave down? Yes, Luke?
Whether the slope is increasing or decreasing?
No. Slope is increasing. You could have positive slope and still be...
Increasing.
Yeah, you still have positive slope, but you're still going to be concave down. You can have that. Yeah, so what can you tell? Yes, Eva?
Isn't it, if it's U-shaped, it's concave up, and then if it's S-shaped, it's concave down?
U-shape is what? Concave down?
Concave up,
Concave up? Okay, and as what?
and then N-shaped is concave down.
Okay, yes.
The slope is increasing at an increasing rate?
You can... That's a concave up or concave down?
That's concave up.
Increasing at an increasing...
Increasing at an increasing rate. It's accelerating upwards.
Okay, so that one is actually... Okay, so the way to tell is actually looking at a tangent line. It's not U and N, but the closest thing for student to understand is going to be U and N. So if something that's U is going to be concave up, something concave down is going to be N. However, concavity can be told by looking at a tangent line. Whether tangent line is above or underneath. Do you guys remember that or no? Okay, so what I mean by that, so if you have a tangent line, let's just say if you have, let's just say if I have something that, just say if I have something tangent line, let's just have something like this, a sine function, just go with sine functions here, right? So sine function is, here you can tell from U and N, so this means this region is going to be concave down, right? Concave down. And this region is concave up, like concave up. But the reason why it's not U and N is really determined by the tangent line. So if you look at the tangent line here, that tangent line is above the curve, right? It's above the curve, then it's concave down. Okay, now if you see the tangent line is below the curve, if I trace out the tangent line is below the curve, then I can see that it's concave up.
Is
And
this a derivative?
this is original function. Original function. This is just f of x. So how can I tell which side is concave up, which side is concave down? You look at the tangent line. Tangent line is above. If I draw the tangent line at that moment, guess what? It's concave down. Because the tangent line is above. Does that make sense? Okay, yes, Jonathan.
When would U and N not work though? Like
Well, the thing is not U and N is not working. It's working. But the true thinking is going to be go by the tangent line. So I'm going to show you what happened if I do it on decimals, right? If I do it on decimals and not just create any function, that just says f of x, what kind of function you want to do? F of x equal to what? I don't know.
3x cubed minus x squared.
Okay, 3x cubed. Okay, that's fine. 3x cubed. I think that's a good one. So 3 minus 2x squared. Okay, that's a very, very good one. The reason why I don't entirely like this one, but I'm going to talk about which one I do like, but this one's okay. If I just do this, I'm going to draw an equation tangent line at every moment. So I'm going to show you how to do it. It's actually y minus f of x, f of a, right, is equal to a is some type of arbitrary x value. It's equal to what? F prime of x. So f prime of A, f prime of A, is equal to parenthesis x minus A. So you see that as a tangent line. Do you see that tangent line is below? It's concave up, right? And you see that this thing is changing, right? Now you see this is still concave up because it's below, right? And then when you get to here, then you see they are concave down now.
Yeah.
So somewhere along the line there is a inflection point here, roughly, I don't know where, but there was somewhere around the line it's a change, right? Do you see that change? That change happened around 0.2 because 0.2 is not up or not down. Do you see that the tangent line is not really above or below at that particular point? It's almost exactly the same. So you say, wait, how does that work, right? How does that really work? So in order for you to find that, and sometimes you got a situation that you might not change the concavity, you might have a difference. So in this case, there's a concavity, there's a change. This point is called inflection point. Inflection point is where the concavity changing from down to up or up to down. Okay, so, and tomorrow we're gonna get to talk about a good way to memorize this. So we're gonna talk about second derivative. The second derivative is basically tell you concavity, and that's very important. So second derivative, so test for concavity. Test for concavity is f double prime of x is greater than 0 is concave up. F double prime of x is less than 0 is concave down. Simple thing like that. Okay, and the point inflections is the point the concavity change. So f double prime of x changing signs. Changing sign. So it went from positive to negative. So f double prime, it can change in from positive to negative, right? Positive to negative. Or negative to positive. Either way, that's true. Are we okay here? So how do I do this function? So if I just have x to the fourth minus 4x to the third, I can take a first derivative. First derivative is what? 4x cubed minus 12x squared, right? And how do I second derivative? Okay, so good. So we just take it out and we change it to factor form. The reason why we change it to factor form is going to be x minus 3, and this one is going to be 12x times x minus 2. Does that make sense? So if I would do number line test on the first derivative, what will happen? Well, we have a 0 and 3, and we have 4x squared and x minus 3. This one is always positive because it's square. Am I going too fast? And this one is 0, so if with -1, it's going to be negative, negative, positive. So positive, negative, negative. So it's decreasing, decreasing, increasing. Does that make sense? No, this is not point inflection. At 3 is what? Minimum. Good job. Okay, so at 0 and 2, and if I have 12x, here it's going to give you negative, positive, positive, and the x minus 2 is going to be what? Negative, negative, positive, positive, negative, positive. So it's going to concave up, down, and up. Does this make sense?
Yes.
So what's the first derivative tell me? The first derivative told me says at x equal to 3, I have a relative min. And the second derivative tells me that I have x equal to 0 and x equal to 2 is actually a inflection points. Are we okay here?
Wait, sorry, why did you do the first derivative?
I take a first derivative and I take a second derivative.
But is that first number line test for the first derivative?
Yeah.
Why?
I just want to kind of show you how to sketch this whole graph with our calculator.
But we didn't need it to find the answer.
We don't need that to find an inflection point, but I just want to show you, if I give you x to the 4 minus 4x3, without calculator, can you sketch it? On AP exam, they actually, in the past, in 1980s, they actually just give you a function, and UCF still does that. So UCF, they give you the first derivative and second derivative. They did it for you. And they says, can you sketch the whole function out of the information it's given to you? So it's different than how AP exam is gonna ask. I'm not preparing you just for the AP exam. I prepare you, even you go to UCF or UF or MIT, that you can actually knowing how the curve sketching works. So that's how you're gonna sketch all the things. So basically, I'll have some points I need to find out. So it's x and y, right? So first derivative, actually, the original function actually can tell me like something. So it can tell me at x equal to 0 and x equal to 4. That's also equal to 0. Does that make sense? Because you got zeros there. And then 2 and 3. So what happened when x is equal to 2 in the original functions? What happened when x equal to 2? I think I'll get negative 18. I think. 16, sorry. Okay. Sorry, I ran out of time. And this one is going to be negative 27. I recorded, I just sketched in the last part. The last part is pretty easy. I mean, if you want to stay over, I'll just show you how to do it very quickly. So this is 0. And this one is going to be negative 16. And here is about negative 27. So basically, it will at 2. At 2 is going to be at negative 16. And at 3 is going to be at negative 27. So basically, you're going to sketch like this. And at 4 is going to go up like this. Just draw the dotted line with increasing and decreasing. Now I will go through the concavities. And also write down the inflection point, which is the red part. And then basically just follow this. And basically that's the whole graph. So basically just follow the concavity and follow the down and follow the up. So then you can sketch the whole graph. Ashable, I need to talk to you.